Google has a reputation for solving hard computing problems, but not particularly for doing much in the education space. I'll say up front that we are not experts in education. You're the experts and future leaders of education. And what I'll try to do in the brief time I have is explain how we're here to help that and why we're interested. But to do that, I have to digress a little into my day job, which is working on Google Maps. So one of the hard problems that we face when we draw the map itself is placing all the little textual labels. What we want to do is, for important buildings like Olympia, where we are now, we want a nice big label for that building and a nice big font so it's really easy for people to see. The trouble is, when we do that, it ends up overlapping all the nearby streets, so you can't see the streets anymore. So then we think, OK, well, we'll just move the street labels away a little bit, and then it overlaps with other things. And this knock-on effect means this problem is really, really hard for us to solve. And when we say a problem is hard to solve from a computer science standpoint, we don't mean in a loose way in the sense you might say, this Sudoku is hard, or this physics homework is hard. We actually have a formal mathematical definition of how hard a problem is. And that's really important, because it turns out that some problems are so hard that even with our computational resources, we can't find an exact, perfect solution. Everything is always going to be approximate. We have to rely on heuristics. And if that's the case, we need to know that up front before wasting years and years of engineers' time on finding a perfect solution. It turns out that labeling the map is one of these problems that is impossible to do perfectly. And that whole branch of mathematics was actually founded by Alan Turing, the famous British computer scientist. You've probably heard more of Alan Turing's efforts to break the Enigma code and speed the end of World War II. But in his spare time, he was founding the entire of the theoretical underpinnings of modern computer science. As a side, if you want a practical maths problem, it's kind of surprising that in a talk about the future of education, 2 talks back-to-back have had World War II references, which is a little bit odd. But so the UK has this really rich history in computing. In addition to Turing, probably not many people know that the first computer used in an office environment in the world was here in London with Lyon's Tea Shop in 1951. Lyon's Tea Shop famously being pushing the edges of computing, but that's where the first computer was. So we have a really, really rich history. And the present is also pretty good, too. In the gloomy environment that we have today, software engineering, high-tech industries is really one bright spark. Google has been growing its presence here, its engineering presence in London for 5 years now, and will continue to grow in the future. Little Big Planet, that was referred to earlier, Grand Theft Auto, these world-class computer games were developed in the UK. Films such as Lord of the Rings, all of the computer software used to do the dramatic visual in Lord of the Rings, also done in the UK. So you would think that between our amazing history and our current bright stellar presence, that we would have this wonderful talent pipeline of students coming through schools, coming to universities, and eventually, hopefully, ending up working for people like us, or for Double Negative, or the many other high-tech companies in the UK. Unfortunately, that just doesn't happen. Since 2003, the number of students studying computer science at UK universities has fallen by 20%. When Nesta actually went to ask young people in schools, if you wanted to go on and make a world-class game like Little Big Planet, what should you study at university? Only 24% of people said computer science, despite it being the key thing. When they asked teachers the same thing, presumably none of you, but teachers the same thing, 5% said computer science was a school. So there's clearly a problem there. If we just think back for a second about what's happened in the technological landscape since 2003, 2003 was 1 year before Facebook launched and 3 years before Twitter launched. And if you think about this pace at which those things have changed society, and during that same time, the number of people studying the subjects required to make that change at university fell by 20%, that makes me very worried. From a I won't deny there's some self-interest. From an engineering standpoint at Google, I'm worried about being able to hire enough people to work here. But for a UK society as a whole, to not have that background is quite scary to me. So that's why we see it as being a big problem. I mentioned earlier that we're not educational experts. I'll apologize up front. I'm not going to espouse a wildly new, disruptive way to teach education, great ways to excite students, that kind of thing. I'm not here to teach people how to teach. I'm hoping that many of you are in a position to do that. And hopefully some of the things that we can do is offer you practical support to actually make that possible and actionable. So our intervention with education is focused mainly on STEM, science, technology, engineering, maths, because from the problem that I outlined, that's the most important set of subjects to us. Increasingly, we really feel that the cross-curricular nature of these things is super important to do anything useful. And there's a lot of motion to try and get STEM rewritten as STEAM and include art in the whole technological education landscape, and that's something that we're very supportive of, and hopefully we can touch on a bit later. But there's 3 practical ways that we're trying to help in education, hopefully some that you can make use of in the future. First, and most importantly for us, is to actually inspire and excite kids about science, technology, and maths. The second is to offer support for individual teachers in classrooms and programs, and also to speak out and actually kickstart the computer science education debate, which recently we've had quite a lot of progress from with the discussions about ICT. So the first, inspiring kids, this is where the bulk of our effort goes. We feel this is the most scalable way we can contribute to education as a whole. It's very easy for us to touch a large amount of children with a small amount of effort on our expenditure. And we're always looking at Google for scalability in everything that we do. Some recent survey by Intel, they surveyed children and found that 2/3 of them did not even consider a career later in life in engineering. And one of the key facts of that was exposure. And once they actually went out and told children and made them aware of the kind of things that you could do with engineering, that figure fell by half. So this inspiration and outreach is really important. To that end, there's a number of things we're sponsoring. We are sponsoring a new gallery at the Science Museum, due to open in 2014, called Making Modern Communications, and also a £1 million exhibition on Alan Turing's work. In addition, we're focusing on Alan Turing's work at Bletchley Park by helping them build a new gallery there to show off that work. And also the Dublin Science Gallery we're supporting, because I think, as everybody realizes, if children are excited and passionate about a subject, they're obviously going to be much more engaged and much more effective learning, and this is one way we can jump in there. Of course, we recognize that although these big museum attractions are great for the people they reach, they don't reach everybody. You have to be in an environment where you're actually taken there, and that clearly doesn't affect everybody. So we do more targeted grants. We have a set of awards that we call the RISE Awards. These are awards of up to £10,000. They are open for nominations now, so if you have great ideas, you can go and sign up for one of these awards. And we're looking for any practical ideas to help promote technology. A couple of things that we currently fund are Teen Tech, which is a kind of a meetup environment for children to discuss and be inspired by technology. And outside these awards that anybody can apply for, if we think that there is specific merit, we will make one-off investments, as we do in the Generating Genius program, a program that provides long-term, like 5-year-long mentoring support to gifted children from disadvantaged backgrounds in the UK. We also think that while aspiring singers have X factor to dream about, we don't really have the kind of the same thing for science. So we try to push the glamour aspect of this and encouragement through competitions. So it's great to see the Wolfram competition Conrad mentioned earlier. So we fund a Trailblazer Prize at most of the large science fairs, where we try to highlight projects that really do focus on bringing a bit of software and computing and technology into science. I was lucky enough to judge that last year, and some of the projects are really inspirational. There was one young girl just about to start A-levels, hadn't decided what she was going to do for either A-levels or university yet. And she made a device to detect when old people fall down, and this was because she had a relative who recently had a nasty fall and nobody found her. So it's a tiny little device that you clip on your belt, and as you walk along, it does nothing, and then when you fall over and have a dangerous fall, it would automatically call for help. Now, as you can probably guess, it's kind of difficult to tell just from somebody's movements when a normal walk or a jog turns into something that could be dangerous. So to do that, she used a little bit of software. In fact, she prototyped the software in Wolfram's Mathematica. But the main thing is, she didn't really see that software as a means to an end. It wasn't something that was particularly interesting her. She saw a real-world problem that touched her family emotionally. And because she'd been exposed to computing at some point during her school time, she had that in her toolbox, and she could just drop that in with a bunch of other things she'd learned in technology and CDT and build something that could actually go on to be a life-changing device. So having this computer science taught in schools to put it in the toolbox of children so that they can weave it into other disciplines, I think is super important. Another aspect that we will try to weave a cross-disciplinary approach in is the animation festival run by Manchester University, which is a yearly competition for animations, the computer-based animations created by children using applications such as Scratch and Alice. And it's a big prestigious event and lots of exposure for children, and I think it's quite an exciting way to drive the fact that computer science, when coupled with other subjects like art, can really make a difference and allow people to create something exciting. We have our own science fair coming up this year. We try to differentiate it by making it inclusive. So rather than being regional, we're running a global science fair. We asked for applications for projects from all over the world. And so far, we've had 10,000 applications from over 90 different countries. So, as I say, the inspiration is the thing that we can be most effective in doing, but we also offer actual hands-on support to individual people wanting to make a difference in their own individual learning environment. So, as you heard, Michael Gove signaled the opening of the curriculum to turn ICT and to bring in more interesting aspects. And obviously we're very pleased with that announcement, but we're cautiously optimistic because the difficulty would be in the actual practical implementation of it. And we like to think one way we can help is support grassroots efforts that will incite the change necessary that has allowed. There's a couple of things we do there. We have a separate set of awards called the CS for HS Awards. Again, open now if you search for CS for HS. And that's money that we give to programs that try to look at ways that teachers can introduce computer science into schools. A couple of the things that we're funding at the moment are Greenfoot, which is an environment done by the University of Kent to teach programming in a really simple way in the Java language for children. Also, Queen Mary University publish a magazine called CS for Fun, which highlights the kind of fun, practical aspects of computer science and gives children ideas of what they could go off and build with. Again, the Bridge 21 initiative again from Trinity College in Dublin is another exciting cross-disciplinary approach where they look at ways where you can repurpose Wii technology to build something exciting. We had our own program for developing simple applications on Android called App Inventor, which MIT have taken on. It's a simple environment for creating Android applications that children can pick up and use pretty easily on just regular off-the-shelf devices that they likely already own in many cases. And in addition to actually providing cash support for these kind of grassroots efforts, we're keen to look at ways in which existing Google products can themselves be used to support education. So for example, YouTube, as well as being the world's best source of cat videos, there's also a lot of great educational content on there. The Khan Academy, for example, publishes free lectures on a variety of topics. And we recently grouped together a bunch of educational resources into this YouTube for Education, which should make it much easier for people to come and find the resources that are already there. Obviously, finding ways to get to the children themselves is only one half of the problem. Empowering teachers and training the teachers is a huge part as well. And to that end, many of the projects that we try to fund through our CS for HS awards, actually a large part of that is a story around how you empower teachers and how you teach teachers. So for example, the Greenfoot programming environment I mentioned earlier, there's a whole community called Green Room, which is all centered around how do you, getting the teachers together to talk and discuss how you actually implement this in practice. Probably the most important thing we're involved in at the moment, given Michael Gove's recent announcements, is the Computing at School group. So this is a group set up by the British Computer Society, and they provide a curriculum for teaching computer science at Key Stage 3 and 4 in schools that you can just take and use. That's something that we've funded by support, and we also provide some technical encouragement when necessary. But this is an existing resource that if people are wondering how you could possibly implement teaching of computer science in schools, given the freedoms that Michael Gove announced, it already exists, and you can just pick it up and find a way to incorporate it. Probably one of the key things where we had a lot of action is just Google's brand name means we do have the potential to raise the visibility of a particular topic. For example, Eric Schmidt's McTaggart lecture, where he referred to the fact that the UK risks throwing away all the history we have if we don't pick up and start teaching technology back in schools. He managed to bring quite a high profile to that issue, and I'd like to think that in a very small, tiny way, that was in some way led up to the recent announcements around ICT. But certainly, as I say, we don't want to espouse a particular way of learning. We're just keen to draw public attention to the issues that we think are vital to the future of society right now. So like I said, we also sit on the Royal Society's advisory group for computing in schools. They're supposed to be releasing their report this month into what they think the future of computing education should be in schools. So I think obviously the key things that we think about here is we're not underestimating the importance and how long it will take. We see this as a problem for ourselves, for our hiring process, but we also see it as a problem for society as a whole, because to be a successful, functioning person in the modern world, where we rely so much on the power of software and the change it can enable, you really need a concrete grasp of the fundamentals of computer science to do that. And hopefully, in our own small way, we can push that forward. And we also don't see this as a short-term thing. Obviously, any changes we're talking about here have a lead time of 5 to 10 years to take effect. It's not something that we want to just put a lot of focus on and then abandon. It's definitely something we want to push for in the long haul. So I think with that, hopefully that's given you some possible practical resources to look at. And I encourage you all, if you have projects or ideas that you think are interested, to look at things like the RISE Awards and the CS for HS Awards, and maybe we can provide financial support to make that happen. Thanks.